Facilities face infrastructure performance limits. For many facilities leaders, infrastructure risk does not announce itself through failure. It shows up as tighter operating margins, rising maintenance hours, unexplained performance drift, and systems that still function, but no longer comfortably. The problem is not that infrastructure is suddenly failing. It is that facilities are now being asked to deliver levels of performance their physical systems were never designed to sustain. Across commercial and industrial sites, asset expectations have quietly shifted. Buildings designed for predictable loads are now supporting denser equipment, longer run times, stricter uptime standards, and growing electrification. At the same time, maintenance budgets and capital cycles remain anchored to assumptions made decades ago. The result is a widening gap between what infrastructure can reliably deliver and what operations increasingly demand. Infrastructure has not kept pace with operating reality. Most U.S. non-residential buildings were constructed before modern energy, digital, and resilience requirements existed. According to most U.S. non-residential buildings were constructed under very different operating assumptions than those in place today. Data from the U.S. Energy Information Administration's Commercial Buildings Energy Consumption Survey show that roughly half of U.S. commercial buildings were built before 1980, reflecting an aging building stock shaped by older load profiles, climate expectations, and reliability standards. Newer construction represents a comparatively small share of the total inventory, meaning most facilities leaders are managing systems designed for past conditions rather than current performance demands. Industrial facilities show a similar pattern, with core electrical and mechanical systems often extended well beyond their original design life. That age alone is not the problem. Infrastructure can operate safely for decades when loads, duty cycles, and environmental conditions remain stable. What has changed is the operating context. Facilities are now expected to support higher electrical loads from automation, electrified processes, and digital equipment, tighter indoor environmental controls, reduced tolerance for downtime, greater exposure to extreme weather variability, new resilience expectations from insurers, customers, and regulators. These pressures compound. A transformer or switchgear rated for occasional peak loads may now be operating near capacity for extended periods. HVAC systems designed for moderate climate variability are being pushed harder and longer during heat events. Backup systems installed for rare outages are now part of routine contingency planning. Infrastructure that was once adequate becomes fragile not because it is broken, but because it is being asked to perform continuously at the edge of its design envelope. Performance drift is the early warning signal. One of the most dangerous aspects of infrastructure stress is that it rarely presents as a single, decisive event. Instead, it emerges as performance drift. Facilities teams report rising work orders, increased manual overrides, shortened maintenance intervals, and greater dependence on temporary fixes. Systems still run, compliance is still met, but margins narrow. This matters because most asset management frameworks are calibrated around failure avoidance, not performance degradation. A boiler that runs inefficiently, a chiller that struggles during peak demand, or an electrical system that overheats under sustained load may not trigger immediate alarms, but each increases the probability of future disruption. The American Society of Civil Engineers has repeatedly highlighted this dynamic across infrastructure sectors, noting that aging assets under increasing demand exhibit nonlinear failure risk. Performance declines gradually until stress thresholds are crossed, at which point degradation accelerates rapidly. Facilities leaders are often the first to see these signals, but the hardest to escalate them. Performance drift rarely fits neatly into capital approval frameworks that prioritize visible failure or regulatory mandates. The hidden cost of overextension, running infrastructure beyond its original design assumptions, carries costs that rarely appear on a single balance sheet. Operationally, it increases maintenance labor, spare parts consumption, and energy inefficiency. Financially, it raises exposure to unplanned outages, accelerated asset replacement, and insurance scrutiny. Strategically, it constrains flexibility. Facilities become less able to accommodate new equipment, production changes, or electrification initiatives. there is also a human cost. Facilities teams absorb the pressure of keeping systems running under increasingly unforgiving conditions. Knowledge becomes siloed. Institutional memory replaces documentation. Risk tolerance becomes normalized. This is not a failure of execution. It is a structural mismatch between infrastructure design and modern performance expectations. Why this is becoming a board-level issue. Infrastructure stress used to be containable within facilities operations. That is no longer the case. As uptime expectations tighten and resilience becomes a strategic priority, infrastructure performance increasingly intersects with enterprise risk. Downtime affects revenue. Energy inefficiency affects margins. Capacity constraints affect growth plans. Boards and executives may not see the mechanical room, but they feel the consequences when infrastructure limits force trade-offs between reliability and expansion, resilience and capital discipline, or compliance and flexibility. Facilities leaders are now operating at the front edge of that risk, often without the language or data needed to reframe infrastructure stress as a strategic issue rather than a maintenance problem. What facilities leaders are being forced to reevaluate. This shift is forcing uncomfortable questions. Are current performance expectations realistic given asset age and configuration? Which systems are operating closest to their true limits? Where has performance drift been normalized rather than addressed? Which infrastructure risks are invisible to senior leadership? Answering these questions requires moving beyond static asset registers toward dynamic stress assessment, understanding not just what assets exist, but how they are being used today. The strategic implication infrastructure was not built for today's operating reality. Facilities teams are bridging that gap through ingenuity, experience, and effort, but those are not substitutes for structural alignment. The risk is not that systems will fail tomorrow. The risk is that organizations continue to assume performance that infrastructure can no longer reliably deliver until options narrow and costs rise sharply. Facilities leaders are no longer just caretakers of buildings. They are stewards of operational resilience in systems under growing strain. Recognizing that shift is the first step toward addressing it. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.